Hi, my name is Derek, Executive Coding Officer for KITE, and welcome back to the free KITE Python course. In the last video, we went over conditional statements. Today will be short and sweet. We're going over Python built-in functions, which is chapter 4 of the textbook, linked in this video. So first, what is a function? A function is a named sequence that performs a computation. You can think of a function as a predefined set of instructions that can be executed for some sort of specific purpose. You can make your own functions, which you'll see in the next lesson, but Python already has a lot of functions made for you. I'm sure you're already familiar with some of these, like print and type. To call one of these built-in functions, simply type the name of the function followed by a set of parentheses. And sometimes a function needs what is called an argument. An argument is just kind of an input that you give the function, and you put these in the parentheses of the function. For instance, you can see here that print is taking the argument of type 32. When you give a function an argument, it takes that input and performs some sort of sequence of code using that input, and the output of the function depends on what kind of argument it gets. For example, when you say print hello, it will print the word hello. When you say print goodbye, it obviously won't print the word hello anymore, it'll print goodbye. While functions like print will actually do some sort of action, other functions like type here will be returning a value which you can print or store in a variable. Now Python has a lot more of these built-in functions other than just print and type, and I'll show you some of these other ones that are commonly used starting in the next slide. So some of these other functions that we're going to start with are max, min, and len. And I'll just jump straight into my text editor and show you how some of these work. So here I've already set something up that we can use to test out these functions. I won't go too in depth about what this is in this lesson, but all you need to know is that this is a variable, which I named numbers, and it stores 4 individual numbers as a list, 10, 5, 34, and 21. I'll show you how we're going to utilize this list with these functions. So first is the max function. So I'm just going to declare a variable called max number. I'm going to call the max function and send the numbers as an argument. So what this is doing here is that max should return the highest value in the list, and it takes the list as an argument. So let me just print out the return value, max number. So since it returns the highest value, what it should return, since we have a list of numbers here, the highest number should be 34. And note that this also works with strings. So if I just adjust this slightly, the max number can be used taking a string as an argument. So if I send the word hello and I print out the return value. So what this should do is that there's no real way to, obviously you can't compare letters numerically in like a human sense, but what computers do is that it will return the letter that comes latest in the alphabet, which in this case should be an O. Yes, it should be an O. Because out of all these other letters, O comes latest in alphabetical order. And the opposite of the max function is the min function. So let's just start over. So if I declare a variable called min number, I call the min function instead. So what this should do this time is that it will return the value in the list with the lowest value. In this case, that should be 5. Yep. And this also works likewise with strings. Only this time, it will take the letter that comes earliest in the alphabet. So here, this time, I believe it should return the letter E. Yes, because E comes first, before any of the other letters. in alphabetical order. So that is basically the basics of the max and the min function. And there's one more function which I'll like to include here, which is the len function, which is short for length. And it'll return the length of whatever you send as an argument, and it'll return an integer. So for example, if you send this list, let's just make a variable. If you send the list numbers I have here, and I'll print out the return value, it should return 4 because this list contains 4 items. Yep, it should return 4. And likewise, with max and min, you can send strings as well. So for example, if I send the word hello again, actually this time I'll make it a little longer. Hello world. So it should return the total number of characters in this string, which is 11. And note that len does include spaces as counting toward the length of the string. So moving on, type conversion functions are also part of the library of built-in functions that Python has to offer. Since we already went over these in a previous lesson, I'll go over these very quickly. So here you can see that we have a number in the form of a string. We can convert it back into an integer with the int function or into a decimal with the float function. Or if we have a decimal, we can convert these back into integers, in which case the decimal part will just kind of be cut off. There's no sense of rounding up or rounding down. It's just simply gone. It gets deleted. We can also convert these numbers back into strings if we like. Oh, and obviously we can't convert words into integers or floats. So I'll just go into my text editor real quick, show you a couple of examples where this might be useful. So let's say that I have a variable x that is 2.3. Right now, x is a float, right? And let's say that we want to print the number is and whatever x is. So basically what I'm saying here is that the number is and then whatever x is. And basically what this is that this is called concatenation, which is when I combine or smush two strings together by putting a plus sign between them. But the issue here is that x is not actually a string. So if I try to run this code, it's going to give me an error. So to fix this, I have to convert x into a string by using the str function. Now, if I run it, it will print what I actually want, which is the number is and then whatever x is, which is 2.3 in this case. So you can see how the str function can be useful when dealing with concatenation and numbers. Let's look at one more example. So let's say I still have the variable x, and this time I'm going to make it equal to 10, but in a string form. And I want to print 5 plus whatever x is. Well, if I try to run this right now, obviously this won't work. It's going to give me an error right here because I can't add the number 5 and a string. So I have to convert x from a string back into an integer or a float. So now if I run this, you'll see that it prints the correct output of 15. So getting into our next set of functions, sometimes we may want to perform math in our program that's more complex than simply just adding or subtracting, or multiplying or dividing. And that's where these math functions come in. The only difference with these is that we are not able to use these right away. First, we have to type this line, import math, and only then can we actually utilize these functions. And this provides a wide array of things that you can use, like exponents, square roots, even trigonometry. An additional difference is that we also have to use this dot between the name math and the name of the function. It simply just refers to the fact that this function comes from math and not from anywhere else. So let's just try jumping in, take a look at some examples of these math functions. So first, we need to import math. This gives us access to a huge library of built-in functions for math and also some predefined variables. One example of these variables is math.py. I'm just going to print out math.py. And this variable gives you a much more precise value for pi, much more accurate than just typing 3.14. And you can see this when I print it out. It's going to give me a super long decimal. And this will be useful if you need to do math with pi. So going into the functions now, one example is math.square-root, which gives you the square root of the argument. So in this case, I'll make the argument 4 and print out the square root, which should just be 2. Another function is math.log, which takes the logarithm of a certain number. And this function actually takes 2 arguments. The first argument is the number that you want to perform the operation on, which I will make 100 in this case. The second argument is the base of the logarithm, which I will make 10. So if I print this now, it should return also a value of 2, because 10 squared is 100. However, for this function, the second argument is actually optional, and if you don't provide one, it will default to e, making this a natural logarithm. So if I delete 10, this will now default to a natural log. And you see if I run this, it'll give me a much more ugly number because e to the power of that whole thing is 100. And I'll show you one more function from this math library, which is math.sign, which takes the sign of a number in radians. For example, I'll actually use the math.py variable here. If I do 3 times math.py divided by 2, this should give me an output of -1. So note that I just scratched the surface of all the possible math functions there are. If you want to go take a look at the full list of available functions and variables, you can go to this link here and it'll show you all of them. So moving on, I'm going to go over one more group of functions, which are the random functions. So sometimes in your program, you want to have some sort of aspect of randomness or randomization. For example, rolling a dice, a random number generator, or flipping a coin. So in order to implement this, you can use a random function. Similar to the math functions, they must also be imported with this line, import random, and you must also utilize a dot when calling these functions. So let's go over some examples. So first, let's import random. One function that we can use from this random library is the random.random function. So if I print out the random.random, which doesn't require any arguments, it will give me a random decimal between 0 and 1, 1 being exclusive, which you can see here. Alternatively, we can use the random.randint function. So if I do random.randint, this function takes 2 arguments. The first being a lower bound, which I will make 1 in this case, and the second being the upper bound, which is 10. And this should give me a random number between 1 and 10. As you can see here, note that it's going to only give me random integers, not decimals. And one more example will be the random.choice function. And this function takes a list as an argument and randomly selects one of the items in the list. So for example, I'll just quickly make a list here. I'll make just a random list of some numbers. So it will randomly select one of these items inside of X. And this may be more useful if your program is dealing with non-numeric items, for example. So I can change this also to make this like, if you want to randomly select random car brands for some random reason. You'll see that it'll randomly pick one of these car brands inside the list. So you can see that random gives us a lot of different ways to implement unpredictability in our program. Now, once again, there are so many more random functions that I have not gone through, so you are free to check out the full list with this link here. Alright guys, thank you for listening to today's Python lecture about functions. In the next lesson, we're going to create our own functions to use. If you have any questions, join our Discord server, which is linked below. There you will have complete access to forums where KITE representatives can answer questions or concerns about certain exercises. Have a great rest of your day, guys.